All right, this is lesson 421. You can see the objectives of this lesson 4.2. We're going to learn how to figure out what exponential growth and decay are. We're going to learn how to describe exponential increase and decrease. We're going to learn how to compare exponential growth with other kinds of growth. And we're going to learn to represent exponential growth and exponential decay relationships to algebraic expressions. We need to do a little bit of review because oftentimes exponential relationships involve percents, and there's a certain way I want you to do the percents. So pay attention to the first couple examples here. If we want to find 8% of 300, now normally we would do the percent, so 8 goes over 100, and then out 300 is the whole, so we would put it there, and then we would find the missing number, and that would be 8% of 300. But what I'd like you to do, and normally you would do the 8 times the 300 first, and then divide that by 100. I'd like to change that and ask that you do 8 divided by 100 first. And it won't be long and you'll be able to do that in your head. Dividing by 100 just moves the decimal back 2 places. And then multiply that by 300. So that looks like this. 0.08 times 300 equals 24. All right? So to find 108%, again, I'd like you to divide by 100 first. And that gives you the decimal 1.08. Then multiply that by 300. And that gives you 300 plus an extra 8%, which is 324. Marty bought a CD for $12. Sales tax was 7.5%. Find the cost of the CD including tax. Since we're including tax, we really have two things here. We have 100% of the price of the CD that we are going to add with our 7.5% tax. And that gives us 107.5% total. That's what the price with sales tax will be. So again, I want you to divide that by 100 first. And that's 1.075, and then multiply that by the price, $12. And if you do that, I need to get my calculator up for this one. All right, so I have my calculator ready, and I want to do 1.075 times 12. You've probably already done this by now, but 1.075 times 12, and that gives us 12.9, which in money is $12. All right. All right, that was Matt saying hi. All right, so a sweater, $30 sweater is on sale for $24. Find the percent off. Now, a lot of you just, to find a percent, you would set up the ratio like this and then divide those. And if you do that, you get, if you divide those two numbers, you get 0.8, which is the same as 80%. But that means that 24 is 80% of 30. And we want to know the percent off. Well, if we're left with 80%, then to get the percent off, we need to subtract that from 100%. And that means 20% off. The other way you can figure that out is to just take the amount getting off, which is 30 minus 24, and that's $6 off, and use that as your part, and then use the original price, $30 as your whole, and that's another way to get your 20%. So, all right, use the graph to find each value. So we're using the line right here. And we want to find y when x is 6. So on our graph, we're going to find on the x-axis 6, which is right there. We're going to go up to where the line meets the graph, which is this point right here. We're talking about that point, and the y value is right here on the y-axis, which is 1, 2, 3, 4, 5. So y equals 5. So we're actually at this point, x is 6, y is 5. All right? When y is 0, find x. So y is 0 on the y-axis, that's this one. 0 is right at the origin in the middle, so I need to go find the graph. There's the point right there. Find the x value at that point, which is -4, because that point is -4, 0, and so x is -4. All right, let's do some exponential stuff. This is a cool problem that kind of represents what we're going to be learning about. It says a super ball is dropped from a height of 10 feet. Each time it falls, it rebounds to 3/5 of the distance that it fell. List the heights of the first 4 rebounds. So, and I'm going to show you how to do this on your calculator, but I'll do the first rebound. So we're at 10 feet. And to get 3/5 of that, we just multiply by 3/5. And that's equal to 30 over 5, which is 6. All right? You could also do this as a percent. 3/5 is the same as 0.6, 60%, so we could change it to the decimal 0.6 and just do 10 times 0.6. So that's the first bounce. Now we want to list the heights of the first 4 rebounds. So that would be, make a little table here. And the first 4 rebounds, we'll say 0 is where we started, which is 10 feet. So the first 4 rebounds are these numbers. And the first rebound we just figured out is 10 times 0.6, which is 6. Okay, and then if we rebound again, we're going to multiply that. I'm going to use my calculator to do that. So I start at 10, press enter. Then I times by 0.6 to get the first rebound. And now that I have my answer times 0.6, I can just hit enter. So 3.6 is the second, 2.16, and 1.96. So 0.6, 2.16, and 1.96, something like that. So basically, we're multiplying by 0.6 each time. That idea where we multiply by the same thing every time, so we have a constant multiplier, that is known as an exponential relationship. And the equation will have a certain look to it. We're gonna learn all about that here. All right. So let's explore here. It says, suppose you make up a funny joke one evening. The next day you tell it to 2 classmates. The day after that, your 2 classmates each tell it to 2 people. Everyone who hears the joke tells it to 2 new people every day. So on the 4th day after you made it up, how many new people will hear the joke? Let's just kind of follow that. So we'll talk about day and the number who heard it. Not the total number of people who heard it, but the number who heard it on that day. So on day 0, that's when you made up the joke. You're the only one that heard it. On day 1, you tell it to 2 people, so 2 new people hear it. On day 2, each of those 2 people tell it to 2 people, so 4 people heard it. On day 3, 8 people, and notice we are doubling each day because each of the new people are telling it to 2 more, so that doubles the number. So on the 4th day, there will be 16 people. Now, some of you will notice that those numbers are like exponential, like 2 to the 3rd is this number, 8. 2 to the 4th is, and that represents the 4th day, is 16, and so on. That would, that's kind of how you do it. Now, I'm going to let you finish that Explorer in class. Go down to the next problem. Marcus has 3 fish in an aquarium. Each week the number of fish in his aquarium doubles. The chart shows it. So he starts with 3. Double that, you get 6. Double that, you get 12. Double that, you get 24. And so on. And this chart shows the number of new fish in there. Or the total number of fish. Okay? By what number do you multiply to get from one number of fish to the next? that's 2. And notice we keep multiplying by 2, which suggests an exponent. And this is indeed an exponential relationship. Okay? All right. For a science experiment, Tanya put 1 amoeba in a dish. Each day she counted and recorded in a table the number of amoebas in the dish. How does the number of amoebas change each day? If you look closely, we're multiplying 1 times 6 here, and then 6 times 6 here, and then 36 times 6. So we are multiplying by 6 over and over again. So it changes by a factor of 6. Factor meaning a number we're multiplying. Okay? Now, which expression has a factor of 6? In other words, 6 multiplied by itself over and over again. This is 6 times x, which means 6 added over and over again. This is 6 to the x power, like 6 to the second, 6 to the third, and so on. That's multiplied by 6 over and over again. That's what we want. The last one, x to the 6, means you can take any number and multiply it by itself 6 times. So that doesn't make sense here. So how many amoebas will be in the dish on day 6? Let's use our calculator. On day 3, we have 216. Let's enter that into our calculator. And then we'll count. So 216, enter, and then times 6. This is the 4th day, 5th day, 6th day. 46,656. All right? Okay. Let's see how we're doing. Okay, so Mr. Brooks brought 2 fruit flies to his biology class. He told his students the flies would reproduce and the population of flies would double every week. Lois and Roberto wanted to figure out how many flies. So Lois made this table. I can see it's doubling. Adding 2 again, adding 2 again. Roberto made this table. All right, going to look at those patterns. Whose table is correct? That is, whose table shows the fruit fly population doubling. Well, in the first one, we really aren't doubling after the 2nd day. We're just adding 2. That's not doubling. That's a linear equation, and we're adding a constant on that one. But Roberto's is multiplying by 2 every time, and multiplying 2 is doubling. So we're going to say Roberto's. Roberto's has a constant multiplier, not a constant difference. All right, so how do the 5 population values in the incorrect table change? That one has a constant difference. So, in other words, it's adding the same amount every time. And if you remember from what we learned before, it's a linear pattern. Roberto's is not linear because you're multiplying, not adding. Right? So let's check this out. This is the equation for both of those. And 2 times x means that we're going to multiply 2 times that number. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And so on. 2 to the x power means we're going to use this x value as the power. So 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. And so on. So that one multiplies by 2. So we can see the next one would be 16 there. And x to the second, that means we're going to take x and multiply it by itself. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. You can finish it up. So as x increases from 0 to 5, which expression's values increase most quickly? It's kind of hard to tell for the first 2. Let's put one more on here. And then we can see that this chart right here, 2 to the x, is increasing most quickly. All right, we'll do the rest in class, and I'll see you tomorrow.